Okay, if you're watching this video, then you've already read about the parameters for the Demolition Derby computer program project. If you have not, you need to go do that, or probably print out the parameters and have them with you so that you kind of know what we're doing here. Okay, so the first thing we're going to do here is I'm just going to kind of stake out some space for the interface. I can probably change this later. I'll maybe merge these cells. Mr. Herman's Amazing Demolition Derby. Computer program. Obviously, you're going to be very creative on your own and make your own program. I think that goes without saying. Where's the borders? Okay, so we're going to have 3 cars. We'll have a blue car, a red car, a green car. Let's make these format these columns width 1.1. Yeah, see. Gonna mess things up. That's a little better, I guess. Okay. And I probably should cut. Yeah, yuck. Yeah, that's okay. White. And this is a red car. White font. This is a green car. And you could actually, put pictures of cars in here instead. You should do something way better than what I'm going to be doing here. Okay. Let's see. So we're going to put 3 parameters in for each of these. We're going to put weight in tons. Keep in mind, I'm just showing you how to basically do this. I'm going to actually do a really bad job with the actual computer program, the actual interface stuff. So weight in tons, velocity in miles per hour, and degrees from north. Go ahead and center those. Where's bold? Bold that. Maybe underline. Okay. All right. So so there's only 9 cells that the user is going to enter stuff in. Wait, so we'll go ahead and click on that. I'll click Command, hold down the Command key, and select these other cells because we need to unlock these cells. So click those 9 places where users are going to enter stuff, and then we'll go up to let's see, format these cells, and we click on protection, and we need to unlock them, so we click that. So eventually those are the only cells that a user is going to be able to enter anything in at all. So click OK. All right. So that's helpful. We have some parameters. Let's look at the degrees from north. So let's click on Command and click on all those cells. We got to do some data validation on some of these things. Now, if you look in the parameters, the degrees from north need to be just whole numbers. The user needs to enter just whole numbers. So we don't want to put in like 94.3 degrees. We're going to put in just like 94 degrees or something like that. So I have all those cells highlighted. We're going to go up to Data, What do we need here? Data validation is what we need to do. We need to validate the data that they're going to be entering. And the settings, okay, so validation criteria, allow any value. We're going to do whole number, allow whole number between, and we'll do 0 and 360 degrees. You can click on input message, and you can show an input message when the cell is selected. So you could actually say here, put a or input message, enter only whole numbers or something like that. I generally don't use the input message. I know some of you have in your programs and you kind of like it, and that's great. Go ahead and use it if you want. We definitely want an error alert, and we want to stop them. There's stop and there's warning. Here's what warning looks like. Here's information. We actually want the stop because we don't actually want to do it in the stop. I think Excel has it so that it definitely stops them and doesn't allow them to do it. So you could do a title if you want, or you can just do the error message. I just usually do the error message. Please enter a whole number of degrees between 0 and 360, something like that, and I'll click OK. And so now, if someone comes in here and you type in like 54.5 and then hit return, it'll say please enter a whole number of degrees between 0 and 360. So I'll retry, and I could do maybe 300 and hit return, and it's going to let me do that. And that'll be the case for this one and this one also. Okay. All right, for the other ones, we're going to have a list. The weight needed to be from 2 up to 10 tons, which would be a big car, but nevertheless, that's what we're going to do. So we'll come down here and we need to do a list. So we'll do a weight of 2 up to 10 tons with half-ton increments. So I'm going to do 2 tons, and then I'll do like 2.5, and then once I have these two in there, I can come down, I'll select both of those, come down the corner, grab this, and I'll start going down, and you'll see that it'll actually do the incrementation for me. I want to go all the way up to 10. Whoops, not enough. 10. There we go. So there's my list of tons. Maybe in this list I should click the little decimal button, put it like that. Okay, so there's my list of weights, possible weights that the user can enter. Velocities, I need to go from 20 miles per hour to 100 miles per hour in 5 mile per hour increments. So 25, and I can do the same thing here and go all the way down to up to 100 miles per hour, which is extremely unsafe. Okay, so now what I can do is I can come up here for the weight, and I'll click here, I'll click command and hold this one and this one, and I'm going to go up to data validation again, data validation, settings, allow, and I'm going to choose, from the allow, I'm going to choose a list. And then it says it wants the source of the list, so I'm going to click on this, and let's see, I'm going to move my scroll down. I'm going to grab my scroller, and I'm going to highlight this wait list. And you can do an input message. I'm going to do error alert, stop. Please select a weight 2 to 10 tons in 0.5 ton increments. And I'll click OK on that. Okay. And you'll notice now when I click in one of these things, it gives me this little drop down symbol. I can click on it and it lets me pick something. You can also enter something straight in. But if you do that, then sometimes they do something different, like 4.5, hit return, and oh, I guess that's a valid one. 4.7, hit return, and it says please select a weight between 2 and 10 tons in 5.5 ton increments. So I'll click retry, and when that happens, sometimes I can't click the data thing again, so I'll have to just enter something in straight in. Whoops, I can't use that. Two, something like that. Okay, so the velocities, I'm going to do the same thing. I'm going to do command, and I'm going to select all those, and then I'm going to come down here. Well, actually, I'm going to go up to data, validation, and I'm going to get a settings. I'm going to get a list again. My source code for my list will be these. And I'll click OK. Let's see, I don't want an input message error alert. I'll say enter a velocity from 20 to 100 in 5 mph increments. Okay. Okay, so I have now you'll see I have drop down list for those. All right, good. Okay, let's see. What do I want to do? Let's go ahead and enter some things in here that we can always use. I'll use 2. The velocity of the blue car I'll say is 50 degrees from north. Let's do 190. Red car. Let's do 9.5. Velocity, miles per hour. And I have a program that I've already made that you can download and you can check your data against to make sure it's right, because I hope my program's right. And the green car, let's go 10. The velocity of 45. And degrees from north, 23 degrees from north. So we got some data in here now for these. Okay, so let's start doing some calculations on all these things. Let's see, we can come down here and let's see, what do we want to do? There's in a parenthesis there. It's not very pretty. Okay, what we could do is we could figure out the well, let's just drop some data down here and deal with this. So let's do velocities in meters per second. Oh, very well, let's just drop this data down here. Velocities meters per second. Velocities, or that's miles per hour. Velocities in meters per second. Weight, tons. Weight. Actually, it'd be mass, but oh well, mass in kilograms. So let's just drop some of these down here. Our velocities. Let's see. This is cell D7. So this would be D9 and D11. So equals D7 equals D9 equals D11. So there's our velocities in miles per hour. We've dropped them down there to work with. Weight in tons would be C's. So this is equals C7 equals C9 and equal C11. Okay, so we got our information down here that we can work with on here. I could add these tons here. I could do that by equal sum. Let's see, I want sum, and then I could just highlight those, and that will sum the tonnage. We might use that a little bit later. Let's convert all these velocities to meters per second. So the way I can do that, if you do your dimensional analysis out on a piece of paper, you'll figure out that there's 0.447 meters per second for every 1 mile per hour. So we can do this kind of a nice condensed thing. So if that's in miles per hour, we're going to do equals. We're going to take this miles per hour, and we're going to multiply it using the asterisk by 0.447, which will put it into meters per second. And I can grab that formula and drag it down and get all my meters per seconds. And we might want to do something with the decimals here. For the weight, these are in tons. There's 2,000 pounds in a ton. There's about 2.2 pounds in a kilogram. So if you do your dimensional analysis on that one, you'll see that 1 ton is about 909.1 kilograms. So we're going to do equals, take this cell, which is in tons, and we'll times that by 909.1 kilograms, return, and I can drop that down. Actually, I could drop that down even a little further and get the weight in kilograms for the total thing. Okay, we could do a kinetic energy before, because we know the masses and the velocities of all three of these cars. So the kinetic energy equals, and we want to do this in joules. So we're going to do equals, it's 1/2 mv squared, so it'll be 0.5 times the mass, that'd be in kilograms, would be this one, times the velocity, meters per second, would be this one, caret 2 would be squared. Okay. All right. Let's go one more. You know what? Let's just take this to the nearest whole number. There we go. Okay, and I could drag that down like that and get all the kinetic energies. Now this one here, I want my total kinetic energy, so I'm just going to do equals sum of all those. And those are all in joules. Eventually I want this in kilojoules, so I'm going to do equals this cell, that's in joules, divided by 1,000. So there's my kilojoules. There's my kilojoules of energy at the beginning. Okay. Now to find the kilojoules afterwards, we're going to have to find the velocity. These cars are going to crash into each other. We're going to have to find the total velocity of the 3-car combo. So we're going to have to do some vector addition on this first. But that's our total kinetic energy before, so we'll be able to use that in a little bit. Okay. Momentum is always conserved. So we need to figure out the total momentums before the collision, And this is going to be a vector addition problem because these momentum vectors are at different angles. So we're going to have to add them all together. And then the total momentum afterwards needs to be the same. Okay, so what we can do is we can get these momentums, first of all, let's do it here, momentum. And we'll go ahead and do these momentums in, mile per hour tons. That'll be fine. So the momentum here, the first one is equals mass times velocity. So the tons times velocity equals, and I can take that and drag that down and get all their momentums. Okay, so there's their momentums, but they're, we're going to have to know what angles they are so that we can actually add them up. So that's our momentums right now. So what we need is to resolve the angles into I-hats and J-hats. That'll be the easiest way to be able to do this, because then we can add up the I-hats and J-hats for all three of these momentum vectors and get an overall I-hat and J-hat to figure out what the overall momentum is. Okay. So now what we've received here is the degrees from north. Okay. So one thing maybe we should look at real quick here. Let's see. Because some of these momentum vectors are going to be in different quadrants. Look at this, if I can draw on this for just a little bit. Okay, so we got to kind of remember our signs and stuff. So let's say we have this big circle. Let's see here. Okay. Okay, that's about as good as it's going to get. All right, and so we got a unit circle, if you remember this. Yikes, it's terrible. Okay, now our momentum vectors that we're going to draw on here could be in any quadrant coming out of this origin. So like maybe the first one is a certain amount of degrees from north. So let's say the first momentum vector happens to be up here in this quadrant. There's the momentum vector at so many degrees from north. Okay. The red car though might be in a different quadrant. Maybe the red car, the momentum is like down here at so many degrees from north. So it'd be over 90, something in between 90 and 180. And the green car might be, maybe even in a different quadrant, something like this, where the angle is something between 180 and 270. Okay, so and normally in math, you're doing your 0 degrees over here, but we're doing 0 degrees from north because we're doing headings and we're going around this way. So let's just look at this first vector, the blue one. The blue momentum vector is up here. So, and here's my angle right here. Okay, so if I resolve this vector into its I hat and its J hat, I'm gonna have a J hat that comes up like this, which is gonna be positive, right? And my I hat is gonna come over like this. So this is I hat. This is J hat. It looks a little ugly here. And if I want to figure out what I hat is here, so really this is, I hat is going to be my X value, J hat's going to be my Y value. So this point right here, I could say if this point here is the origin 0, 0, then this point here would be I hat, comma, J hat. J hat. Looks pretty bad. Okay. So what is I hat? Well, I hat is going to be this momentum vector right here, whatever this momentum vector here, and usually when we do a unit circle diagram, we just say that this is 1. But we're actually going to have momentums, as you see over here. So I hat is going to be the momentum times the sine of the angle. And J hat, so momentum I hat equals the momentum times the sine of the angle. J hat is going to be the momentum times the cosine of the angle. This is drawing things not working that great. Okay. So, and that's going to work for any of these things. So even though this momentum vector for the red, is clear down here, and we have an angle of something, in between 90 and 180. Still, if I take the sine of that angle, the sine of that angle is going to be this vector here, and the J hat will be this one here. Even though I'm taking the sine of this big angle right here, the I hat is going to be my X value, and my J hat is going to be my Y value. So that'll work even though I'm taking the sine of any of these angles to get my I hat. Take the sine of this green one right here. If I take the sine of this green, this big angle here, times this, then I'm going to get this I hat, which will be negative. It'll be negative, and this J hat, which comes down here like this, is going to be also negative. Maybe I should have drawn it this right here. J hat, yikes. I hat, doesn't matter which way you draw it. So they'll both be negative for this one. For the red one, my J hat will be negative, my I hat will be positive. And I'll be able to get an I hat and a J hat just by taking the sine or the cosine of these particular angles that are given by the user. So the I hat will always be the sine of the angle, and J hats will be the cosines of the angles. Okay, we might look at that a little bit later, so I'm just going to shrink that down. Okay, so maybe we should come back up here, and I should have put this momentums up here. Maybe that would have been better. Let's do that. So here's the momentums, and it was equal velocity times the weight in tons. There we go. Let's keep it up here instead. So I'll drag that down. I'll go and delete these things, so I'm not going to use those now. Let's see, edit. Let's see what I can do. Clear all. Okay, so there's my momentums. Okay, so I need I hats, which are going to be my X values. I'll say I hat, and these are going to be J hats, so they're going to be my Y values. And so I'm going to take, for the I hat, I'm going to take 100 sine of the angle that they gave me. J hat, I'm going to take 100 cosine of the angle that they gave me. So those would be my I hats and my J hats. Now, one of the problems is that the angle that you gave up here is in degrees, and Excel doesn't do things in degrees, so it calculates everything in radians. So if you just say, take the sine of this angle, it's going to think that's 190 radians. So you need to actually convert that to radians first. Now, you could do that. You know how to convert that probably, but there's an easier way to do it in this one. So we're going to take equals the momentum vector times the sine of, and then usually we'd be able to put the number in there. But what I need to do is I need to turn it to radians. So I'm going to put in radians, and then parenthesis, and I'm going to come up here and I'm going to grab that angle, parenthesis, and then I'll need another parenthesis, and hopefully that should work. Okay. Now I got a negative I hat, which means like negative x value. And if you think about it, it's the 100 is your momentum. It's 190 degrees, which would put it down down in the southwest quadrant, which means you should have a negative x value, which your I hat was. Okay. All right, so that's good. And I can actually drag this down like so. And let's see, I'll have to go and fix some of these because this would be E. Let's see, if that was E, well, that should have been E7. So this one's going to be E9 and E11 is what I want. So this one is E9, and this, let's see, and this one, E11. And whoops, let's kind of fix our stuff there. Okay, hopefully those are right. Okay, there's going to be a really good chance I can make a mistake somewhere around in here, and hopefully I'll catch it later. Okay, so those are all my I hats. All right, my J hats then would equal, let's see, I want to check that again, E31 and E32. Okay, so J hats would equal the momentum times the cosine of the radians of, let's see, well, it was E7, wasn't it? E7, yes, good. And I could drag that down. And then this is going to have to be E9. And this one's going to have to be E11. And whoops. There's my J hats. Okay. So that's my hat and J hat of each one. So this makes it very easy to add these vectors up because we just need to come here and do equals sum of these. And this one's equal sum of these. And now we have an I hat and a J hat of our, basically our resultant vector. Okay. Now, if we want to find what our overall momentum vector is then afterwards, we have an I hat and a J hat, or X and a Y value. We can just do Pythagorean's theorem on that. So let's come up here and maybe do that. So total momentum. This will be the total momentum before the collision, so it'll be the total momentum after the collision also. So total momentum is going to be equal, let's see, square root of I hat squared plus J hat squared, right? Pythagorean theorem. So a squared plus b squared equals c squared. And we're trying to figure out c, so it'll be the square root of that. So there's our total momentum. We've added all the momentums up. Now this is just a scalar right now because we have to actually put the angle where it's going to be. Okay, so there's our total momentum. Now, if we want, so that's going to be our total momentum before and after. So if I want to find the velocity of the 3-car mess afterwards, I can do that really easy because momentum is mass times velocity. So I can just take my momentum, which is right here, and divide it by my mass of the 3 cars, which is all the way down here. We've totaled up the tonnage right here. So I'll divide it by the 21.5, and I'll get a velocity in miles per hour. That'd be the velocity in miles per hour. Right there. Okay. All right. What do we want to work on next? Let's get the well, let's do that a little bit later. So the hardest part about this entire program we'll be taking this 36.5 miles per hour. That's not a problem, and we're going to be able to come up here, you know, now somewhere down in here, and I don't know, we'll say final velocity, and I'll go in here and I'll say equals, and I'll come down here and grab my final velocity like that, and I'll say miles per hour. And maybe put some spaces at and then right here I'll put like the degrees from north. So and then here I could do like degrees, and by the way, if you want to know how to do that degree symbol, it's option K, degrees from north. The hardest part about this whole thing will be getting the degrees from north. That's going to be really, really tough to do. So another thing that we need to do is we're doing kinetic energy lost. So we know the kinetic energy before was right here, 5939 kilojoules. That's before. Total kinetic energy before. After, we can figure that out. That's going to be 1/2 mv squared. After, so that'd be, we need to come up here and convert this final velocity equals this velocity times 0.447. So there's the velocity in meters per second. We need that for our energy. Whoops. Good enough. Okay, meters per second. So that afterwards, your total kinetic energy would equal 1/2, 0.5, times the total mass in kilograms, which would be this, times the velocity of the 3-car mass, which would now be this, squared. Whoops, I need to have that in kilojoules, so I'll take that whole thing, which would be in joules, I'll put that whole thing in parentheses, and then divide it by 1,000. We'll go to the whole number. Rats, I always go the wrong way on that. kilojoules. So lost would be equal to this cell minus this cell. There's my lost kilojoules, which is one of the things we needed to put up in our interface. So kinetic energies lost equals, what was it, this one? Kilojoules. Percent KE lost. And if I want to find percent KE lost, really I don't want to do any calculations up in my interface. I want to do it all down here, and then in the interface basically drop down and to find your answers. So that would equal, this one would equal it would equal this divided by the energy I had before. That whole thing, we put that in parentheses just to be safe. That whole thing times 100. So in this particular scenario, we lost 56.1%. So I could say equals, let's see, percent equals, what cell was it? That one. Okay, so so we got the kinetic energy lost and the percent kinetic energy lost. That part's all done. So a couple things we're gonna have to do still is we need to make a graph of this whole situation, the Demolition Derby graph, and we're going to have to figure out the degrees from north, which is still going to be difficult. Okay, so so we have I-hats and J-hats of all these things. Here's our red car, our blue car. Let's see, I should have done that. Red, this was blue, right? And this was green. And this is total. Okay. All right. So all we need to graph out each one of these vectors is 2 points. Well, we're gonna have the origin 0, 0, and so now what we're gonna have to do is all three of these original vectors need to end at the origin. So we have all these I-hats and J-hats. Like this first one, it goes 17.4 to the left and then 98.5, down. So we want to draw that vector, but if we draw with our starting point at 0, 0 and our final point, these I-hats and J-hats, it'll be going from the origin down the other way. We want it to actually come from down the other way up to the origin. So all we need to do is just change the signs on our I-hats and J-hats to be able to draw these vectors. So my first drawing, let's see, I want to have X. Let's see, am I going to have room here? Let's go over here a little further. So I'm going to have my X value and my Y value. So I want to end at the origin. So I'm going to do 0 and 0 for this first, the red car, and I'm going to start at equals opposite. I just always do opposite of that, and this one's going to be equals opposite of that, and there is my first graph that I would need to make. That's one data set I'm going to put on there. I'm going to start at 17.4, 98.5, and go down to 0. Okay, so I'm going to do that. That's red. That's the red car. Red car. Okay, blue car. And that's going to end at 0, 0 also. And this is going to be equals opposite. There's the blue. And this is equals opposite j hat. It's my y. And then the green car is going to end at 0, 0. Equals opposite green. Let's see, this one equals opposite there. Okay, so those are going to be my 3 data sets that are going to make me put those vectors on. Okay, now afterwards, after we only have 1 vector, and it should be going from the origin out to wherever it's going. So for that, I'll get my total I hat, and I won't have to change the sign on it because that's actually going to where I need it to go. So equals that, and this one is equals that, and so then I should be able to make a graph of this. Okay, so I'll just I'll grab this first one like this, insert chart. We'll do scatter, do smooth lined scatter. Let's do straight line scatter because these are going to be lines. Okay, and that didn't really work that great. So we'll click on this graph. We'll go up to chart, source data. And series 1 was the red car, so we'll call it the red car. We'll click on the X values and come down here and fix this. So sometimes Excel doesn't understand what you're doing. So we'll select the X values, click the Y values, and we'll select those. And that's the red car. Okay. All right. Okay, while we're here, let's go ahead and add more data series. So we'll do add, and we'll do blue car. Get the X values, which would be here. Get the Y values, that should be here. Good. Add green car. Now you'll notice it's putting different colored lines on our graph as Excel does, and it's the colors aren't matching what our colors of our car are, so that can be really confusing. So we're going to have to change the color of those lines here in a little bit. So X values for the green car would be here, and the Y values would be here. We'll add one more. We'll call it after. X values are here. Y values are here. And we'll click OK. And so we have a graph here. Okay, now we got to fix some stuff here. So let's double click on this graph. I think we could do it this way. Marker line maybe. Color. What's that? We want that to be red. Red. Would that work? Maybe I gotta do it on the line. Can't remember how this works. There we go. That was the line I need to change. Line. Okay, actually, by the way, while we're doing this, weights and arrows, we need an ending arrow on this. There we go. Okay, I think we can shrink down the size of this to make it look a lot nicer. It's 1.25. Okay. We'll have to play with that later. Okay, so click OK on that. The blue car, let's see. If we go to chart, where do I go? Chart layout, grid lines, horizontal, no grid lines. Okay, I don't even need any axes. No axis. Vertical axis, no axis. Okay, so we're just going to have a nice thing here. Okay, so this is the blue car. I'm going to click on that one. I'm on line. Color is blue. Weights and arrows. Can't remember what we did. What did we go down to? 1.25 or something. Probably should have these all be about the same. 1.25. Ending arrow. Okay, and the green car actually it's already green. That worked out, but I don't like that green. So let's make it I can click on here for more colors. Let's make it a prettier green. How about a crazy green? Let's darken it up a little bit. Okay. Weights and arrows. 1.25. Is that what we're on? Oh, well, that's your job to make it better. Okay. All right. Okay. And then after, so those are all, see, there's all of my 3 momentum vectors, and see they're all colliding at the same place. Maybe you can make some fire in there or something on the point. Click on this one. Color. Maybe we should keep it purple. No, hold on a minute. Let's see. Yeah. How about a crazy purple? There we go. Weights and arrows. 1.25 and oh wait, no, this one, yes, yeah, we still want it on its ending. That's right. Yeah, it's going to go away. Okay, and there we go. We have a table. Whoops. Come on. Why can't I move this? There we go. And we'd put this up in here somewhere in our interface. Make cool colors and whatever else. You're going to have to do that. So we can come over here and we should be able to change things like 102. Let's go crazy and make it like 290 for the red car. Notice how the red car is going down this. If I click 290 and I hit return, now the red car is degrees from north, is not working. Oh man, did I get these cars mixed up? Did I make a mistake somewhere along the line? Was anybody watching? Yeah. Let's see. The blue. Are these making sense? The blue 190. It's not right. I think I got my red and my blue cars mixed up. My green car 23 degrees from north, that makes sense. The red car looks like it's 190. Oh, where did I mess that up? Why didn't you interrupt me? Let's see. Momentum 100 for the red. Oh, yeah. My blue and my red are turned around. Oh, I guess that was supposed to be blue and that was supposed to be red. You've been screaming at the video the entire time, haven't you? Okay, so that means this was supposed to be blue and this was supposed to be red. It's not that big a deal, I guess. I can come up here and do chart source data. And what was called the red car should be called the blue car. And what's called the blue car should now be called the red car. And of course, so blue. And this one, red. Oh, yes, mistakes can be made. Okay, so now my red car, 102 degrees. That looks like at 102 degrees from north. The blue, 190, good. Green, 23 degrees from north, yes. And then I have my final momentum. So I can change the red car, instead of being 102, like pointing down this way, I could maybe make it something like 290, which means it should be coming up more like this. So if I do 290 and I change that, now I got a red car coming up this way. Okay, good. All right, we found a mistake, got it corrected. Okay, so now there's your graph. Okay, are we ready for the bad thing? Okay, so how do we describe how many degrees this thing, this final momentum thing, is from north? Okay, well, we have a total I hat and a total j hat. So I can figure out an angle. Let's see if I bring this back up here. So like let's look at the red one here. So like for the red car, I have an I hat right here and a j hat right here. And to figure out, I want to figure out, like, if, like, let's say that this was the final momentum. I have an I hat and a j hat for that final momentum. And what I could do to figure out an angle, I mean, I could figure out this angle, right? If I do the tangent of this angle, tangent of this angle would equal my I hat over my j hat. Or like for the blue one up here, the tangent of the angle equals I hat over the j hat. So I could do I hat divided by j hat and do inverse tangent. And that's going to, like for my blue car, if any quadrant up here, that's going to give me this angle, which is the actual angle from north. But if I do, like if I have the final momentum is down here in this quadrant here, and I do I hat over j hat, and I do inverse tangent, it's going to give me this angle here. See? That's not going to be from north. It's going to give me, this particular angle right here, and I'm going to have to figure out, what is it, what is this angle right here? So that's going to be a little difficult. It's not going to actually give me the correct angle all the time when I do the inverse tangent of I hat over j hat. It's only going to give me the correct angle right away if I'm up here in this quadrant. But you'll notice, like if I'm down here in this quadrant here, I'm going to have a positive I hat. I'm going to have a negative j hat. So I hat over a negative j hat is going to give me it's going to give me this angle, and it's going to give me a negative angle. This angle is going to be negative. So what I need to do to figure out what this angle is from here all the way around to here would be I'd have to take 180 plus this angle right here, because this angle is actually going to be negative. So it'd be like 180 minus this angle, and that would give me that. Well, what if it's down here in this quadrant? Here's my I hat is negative and my j hat is negative. So if I do tangent of the angles I hat over j hat, I'm going to get this angle right here. It's going to give me this angle. It's not going to give me the angle all the way around from north. It's going to be this angle. And it's going to be positive. So how do I get the angle all the way around from here? Well, if it's down in this quadrant, I'm going to have to take 180 plus the angle, again, and that'll work. But it'll be plus. Okay, so for both of these, down this quadrant, I can take 180 plus the angle. If it's up in this quadrant, I don't have to do anything because the angle will be my correct one. What if it's up here? what if it's up here in this one? I could do, I'd have a I hat. I actually need to draw it this way, an I hat and a J hat, like this, because I'm going to be getting this angle here. Sine of the angle is I hat. Okay, so if I do it up here, this is a negative I hat and a positive J hat. So when I do my sine of my angle, I'm going to get a negative angle again right here. Okay, I'm going to get a negative angle. So how do I figure out what the angle is all the way around? Well, I would take, in this case, I would take 360. For this one up here, I'm going to have to do 360 plus my angle. So I do 360 plus, because this angle is going to be negative. So I do 360 plus the angle. That would be 360 actually minus this angle, which would give me, this angle all the way around to there. So if it's in this quadrant up here, I'm going to do inverse tangent of I hat over j hat, and that will be my angle. If it's in this quadrant or this quadrant, I'm going to have to add 180 to it. If it's in this quadrant here, I'm going to have to add 360 to it to get my angle from north. So that's tricky. So hopefully you can pause the video if you didn't understand that and kind of listen to that again, because that part was a little tricky. Okay, so the first thing I want to do is find like the I hat over j hat, the angle. So let's see, like inverse tan of I over j. Let's just write that so we kind of know what we're doing here. Okay, and that's going to be for this the resultant I hat and j hat down here. All right, so I can do equals, and of course I'm going to want this in degrees in the end. Right now it's going to be, it's going to figure this out in radians for me. So I'm going to do well, let's just forget about that part right now. Let's do inverse tangent. So it's going to be, and the way we do that is a tan of I hat, this I hat, divided by j hat equals. Now that's in radians. So underneath it, I'll do equals degrees of that. And so I get 76.1943 degrees. And highlight both of these. Fix the, go crazy here. Okay, this one was in radians. Man, radians. This one was in degrees. Okay, now if you look at the situation we have right here, our final momentum vector, or in the end, our velocity, is up here in this first quadrant, which means we had a positive I hat and a positive j hat. So when I did this calculation here, it actually gave me the right angle. That's the correct angle. It's going to be 76.9 degrees from north. But the problem is what if the momentum vector was down here in this quadrant here? It's going to give me, if you remember from this, if down here, if it was down, the final thing was down here in this one, and I do inverse tangent of I hat over j hat, it's going to give me a negative angle for a negative angle, and that angle is going to be from here, and I'll have to add that to 180. So so the problem is that this the angle that I get here every single time is it isn't going to be just the angle from north. I'm going to have to figure out which quadrant is my final momentum vector in. So the way I do that is I look at the I hat and J hat, my total I hat and J hats here. If they're both positive, that means they're up here in this top right quadrant. You know, if the I hat is positive and the J hat is negative, it's going to be down here in this quadrant. If the I hat and J hat both are negative, it's going to be down in this quadrant, right? And if the I hat is negative and the J hat is positive, it's going to be up in this quadrant. And depending on what those situation is, I'm going to have to do something every time. So if they're both positive, I don't have to do anything. I can just print the angle. If they're if the down here, if it's positive I hat and negative J hat, I'm going to have to add it to 180. If it's a negative I hat and a negative J hat, I'm also going to have to add it to 180. And if it's a negative I hat and a positive J hat, I'm going to have to actually add it to 360. So what that means is we're going to write a really big if statement. And it's a little trickier because it's an if-and statement, because I need to know if this is positive and this is positive, then you print a certain angle. If this is positive and this is negative, then you print a different angle. And so this can be really tricky. So here we go. Let's try this out. So equals. And I might want to come up here and start writing it in up here. So equals if. Let's see. If. And normally we would put a parenthesis and see it shows you, you put a logical test, comma, then you put the value that you want printed if it's true, and then comma, and then a value that you want printed if it's false. But what we'll be doing is we'll be doing a logical test. We'll be telling what we want it printed if it's true, and then if it's false, we're going to actually, in this spot, put another logical test. And we're going to keep on going through that till we get to the end and to print something. So for if-ands, though, we need to actually type and in another parenthesis to put our logic here. So what do we want? Let's see, here's a and for, we have a logical 1 and then a logical 2. So let's talk about the first quadrant up here. So if I hat and J hat are both positive. So the first test we'll do is positive. Okay. So if I hat, and we'll click on this cell, if F33 is positive, which means we'll do greater than, or equal to 0. That should work, I think, I hope, comma. And now we're going to do another logical test, and J hat is greater than or equal to 0. So if both of those are correct, now I can put a closed parenthesis on that. Then, see, now I'm back to my logical test. If that is the case, if they're both positive, then I'm going to do comma, and I'm going to, so if that's true, I'm just going to go ahead and print the angle, which we figured out up here already. So I'm going to click on that cell right there and say, okay, print that, comma. Okay? All right. So now what I need to do is I need to do another logical test. Okay. Now if the whole thing works out on my first typing it, it's going to be amazing. So I'm going to do a parenthesis and do if parenthesis and. The easiest way to do this might be just to come and grab this first logical test that I did and just copy it in that spot. Copy. Hopefully this will work. If and comma. Okay, now let's come here and look at this. Okay, let's look down. Let's say it's down here in this quadrant here. So if F33, that's my I hat, is still greater than or equal to 0, but J33 is less than or equal to 0, in this case, then what I want to do is I want to take I30 plus 180, comma. Okay. Then I should be able to copy this whole thing again. I hope. If and I think I might need parentheses in that. I'm going to copy that again. Okay. And this time, I hat is to be negative, so this would be less than or equal to 0, and J hat is also negative, which I already have. I'm going to again add 180. And then I'll copy the if and again. Put it there. And my last one is if F33 is less than or equal to 0, J33, the G33 would be greater than, so my J hat's positive. In this case, I need to take I30 and I need to add 360, plus 360. Like so. Okay. And I have this written somewhere else. I'm just trying to see if I can write the whole thing out. I30 plus 360. Okay. Really, I don't think we need this first statement. Because if we're going to get, eventually you're going to get a, if none of those work, then what do? And you just print I30. I30. Turn, and I'm going to take this first one out. Yeah, that's what I'm going to try to do. So if and this is greater than or equal to 0 and this is less than or equal to 0, I30 plus 180. If and this is less than or equal to 0 and this is less than or equal to 0, take I30 plus 80 again. If and F33 is less than or equal to 0 and G33 is greater than or equal to 0, take I30 plus 360 and then comma I30. Now we need a lot of parentheses on the end here probably, but I'm going to try to return. And it'll tell me that it looks a little suspect. And I'll say, do you want to accept this correction? Which means it's going to put a lot of parentheses on the end. I'm going to say yes. Okay. So I am hoping that worked because right now our final momentum is up in that quadrant. So it did print out what we wanted. Degrees. Okay, but what I need to do is I need to do some other changing here on my, and get this momentum vector, this purple vector, to point some other way to see if it's working. So if I can get it to point, let's take the green one and let's make that come down at a different angle. So green will be at 120. Now my purple goes down. And it says 114.8 degrees, which looks right, I think. So see what happened is on that my I hat is positive, my J hat's negative. So it knows that if it's checking that that's the case, it's going to add 180 to my angle here. See, I got a negative 65.16 degrees, which would be back from this way. It's going to add the 180. Okay, so that one's good. Let's try to get in another quadrant. Let's go. I need to be something over 180 for all of these. 190 and 1 or 200. There, I'm in the other quadrant, and it's 195.3. See, I got both of them were negatives. I got an angle of 15.29 degrees, which would have been from here over, and I added it on to 180. So that looks good. And then 300, 280. Okay, now I'm up in this quadrant. I got a negative and a positive, and so it should be adding 360 to my angle because this angle would be going back this way, and adds 360 to it. I get 286.2 degrees. So from north all the way around to there, 286.2 degrees. I think we're good. I think we're good. Okay, so I can come up here and do, because the momentum vector direction is going to be the same as your final velocity direction. So I have 48.2 miles per hour at equals, I can click that in there. And there's my degrees from north. Okay. Hopefully you understood that. That's the really hard part right there. It took me a long time to figure out how I was going to end up doing that part of it. Okay. One other thing we wanted to do is, let's say that these cars crash and there's no resultant. The resultant is 0. So they all crash like perfectly at all the same angles. So I guess the way to do that is let's make all their momentums. Let's see what happens. Let's make all their momentums the same. And okay, and let's say degrees from north. Let's have this one be 0. Okay, 0, and then I need to see if I want to do this right. It'd be 120 and 240, right? 120. Okay, all right. So you'll notice here that I'm coming in at 120 degrees between each of these, and they all crash here. They all have the exact same momentum. Boom, stick together, stay right there. So my final velocity was 0 miles per hour. Percent kinetic energy loss 100%. I've lost it all because it's not moving at all. But you'll see that I got a degrees from north. It's not moving actually. So I want to what I want to do is I want to say that I don't want this division by 0 part in there. So I want it to say like, final velocity. Instead of all this stuff, I want it to say like none. Like there is no final velocity. Okay. Or maybe I could just make this be my angle from north be 0. So let's just say all right, let's go right in here, and let's say let's do an equals if parenthesis, and the final velocity, which you get right here, if this is less than let's do like something like 0.009, something like that, something really, really small. So if it gets really, really, really small, then I'm going to print out. I'm just going to do quotation. So it's going to print nothing, comma, otherwise I want it to print this angle. Let's do that. Okay, so so now instead of coming and getting that angle right there, I'm going to come here and I'm going to have this be equals I-32 instead. So I could do that. Actually, what I needed to do there was, instead of printing nothing, I should print 0. Let's do that. There. So now I get a final velocity of 0 miles per hour at 0 degrees from north. And I could do it that way. I did this a little bit different in my program. I had it, and if there was no 0 miles per hour, I actually had it. I did if-then statements to actually not print any of this stuff. And you could figure that out probably if you want to. But if in the weird situation where we completely cancel everything out, I want this to not have a division by 0 error. I want it to have it, be 0. So I made a little if-then statement. So now if I actually change one of these just by a little bit here, 170, of course I'm going to get an overall momentum, and you'll see it'll give me the velocity and it'll tell me how many degrees from north it is. If it just so happens that this thing completely matches out, it'll put in 0 instead. Okay, let's see. I think we're almost done. Of course, you're going to make this all look cool and stuff. We're going to do a couple things to finish up here. I think I basically have most of the parameters all met. If we go back to home, or layout, I guess I want to go to, where do I want to go? Layout. I can click on headings and click on grid lines and hide those. That's the last thing you want to do. You'll come down here. We'll insert a text box. This is in my opinion, the easiest way to hide your programming. Drag it over your programming. You'll have to actually click on. You have to click on the line. Let's see. Am I on the line? I think I'm on the line. Format. Let's see. Line. And just do no line. So when you're off of it, that doesn't actually show up. You have to click on it to see where that's at. Okay. One other thing you might want to do is you come down here outside of your interface, click on a cell here outside of your interface like this, and you go up to Window, Freeze Panes. So that way now I try to scroll down, I can't, and I can't scroll away from the interface. Now that's something they can undo later, but that looks nice. So then we want to protect this thing. So we're going to go to Tools, Protection, Protect Sheet. And you're going to type in a password. Verify it, password. And what you want to do here is you want to allow the users of this sheet to select unlock cells only. That's all you want them to be able to select. So I'll click OK. And now I have this program where a user can't select anything here. But they can come up here and they can click in these and change these to various things. And you can see how it changes your momentum graph. Okay, I'm sure I've probably forgotten something, or might have even done something incorrectly on here, but no matter what, that will give you the idea of kind of how you're supposed to do this, and hopefully that'll help you.